Hello, this is Mr. Henry, and welcome to lesson 4.3. Today we're going to talk about graphing using intercepts. If you remember in the last lesson, we were graphing using an XY table. And the XY table always works, but it's kind of a pain in the butt, because when we did it, we were having to solve for the y variable first, then we had to plug in some random x values in, do a bunch of math to get the y coordinates, then plot the points, then draw our line. We're going to see today, using these intercepts, a way we can do that we can graph the same line, but with a lot less work. Okay. Before we get there, we have these three get the goofs that ask us which of these functions match up with which of these graphs. I can tell you right now, they're all wrong. So let's just go ahead and erase this and find out for sure. Now, one thing that we can do here that's going to make our lives a lot easier is, if you remember when we first started this chapter, the way we could check if a point was on a line was by plugging in the x and y coordinates into the function and seeing if it worked out. So for example, this line crosses the y-axis at 1, 2, 3, 4, at 5. So this is the point 0, 5. This is the point 0, 2. This is the point 1, 2, 0, negative 3. So all I have to do is see, does this point work with this line? Or does this point work with this line? So let's check. If we plug in, well, I can tell you this one does not work here. Because if I plug in a 0 for x and a 5 for y, 4 times 0 is 0, but 5 times 6 is 30. 30 does not equal 12. So that one does not work for that line. If I try the second one out, 4 times 0 plus 6 times 2 equals 12. Well, 4 times 0 is 0. 6 times 2 is 12. 12 does equal 12. So this and this one are buddies. They match up. Okay? So now for the second one, I'm going to check this point 0, 5 again. So 3 times 0 minus 2 times 5 equals 6. Well, that's 0. That's negative 10, so that does not work. If I plug in 0, negative 3, okay, so 3 times 0 minus 2 times negative 3, 0. Negative 2 times negative 3 is a positive 6. That worked out. Which hopefully means that this one does match up with that, but let's check. If we plug in 0 for x, 5 for y, does this work out? Well, negative 5 plus 0 is 0. I'm sorry, negative 5 times 0 is 0. Plus 5 is 5, and 5 equals 5. Yes, it does. So that is actually how these guys match up. So we have a couple vocabulary words. We have an x-intercept and a y-intercept. The x-intercept is where the line crosses the x-axis. Now, by the line, we're talking about the function, the thing that we plot the points and draw. So where that thing crosses our x-axis. So let me, for example, if I do that, just draw. So this is like the line we're drawing in. The x-intercept would be this point, right there, where the line is crossing the x-axis. You could probably guess the y-intercept is then where the line crosses the y-axis. So this blue line is crossing the y-axis right there. So that would be the y-intercept. And when we're doing this graphing today, those are really the only 2 points we care about. We can graph our function from just those 2 points. But before we get there, we're just going to do a little bit of before we get to graphing, just a little bit of practice. So we're going to find the x and y-intercept of the graph that. Now, a couple of things to point out. when we are finding the x-intercept is where the line crosses the x-axis. And that point right there is always going to have a y-coordinate of 0. Because think about it, I'm on this x-axis, so I'm not up in the positives, I'm not down in the negatives. I'm right at 0 in y, in the up and down. That's very important to remember. So the x-intercept happens when the y-coordinate is 0. Now, with the y-intercept happens when the x-coordinate is 0. Look, right there, this y-intercept is on the y-axis, but the sideways motion from the origin is 0. So I'd move sideways 0, up or down to my point. So the x-coordinate is 0. This and that is kind of what you want to remember to do these problems properly. So here's how I usually set these up, and I find that this works out pretty well. So we're going to find the x-intercept, which happens when y is 0. And then we find the y-intercept, which is when the x value is 0. Now all I do is I plug in my numbers. So in this side, I'm going to use this function, the same function, but I'm going to plug 0 in for y. So if I take 3 times x minus 4 times 0 equals 12. Well, 4 times 0 is 0, so this whole piece here cancels out. That's just 0. So I've got 3 times x equals 12. Divide by 3. This is solving now, getting the variable by itself. Divide by 3, and x equals 4. So I have the point when the x-coordinate is 4, the y-coordinate is 0. So point 4, 0. That is my x-intercept. On the other side, let's see, we'll use that same 3, but this time we're plugging in 0 for the x. So 3 times 0 minus 4 times y equals 12. This is 0, so it cancels out. So now we have this little one-step equation to solve. Well, the way we get the y by itself is we divide both sides by -4. These cancel. Y equals a -3. So we have the point when the x-coordinate is 0, the y-coordinate is -3. So I have my x-intercept and my y-intercept. The x-intercept is on the x-axis at 4. The y-intercept is on the y-axis at -3. So I can even tell you right now, this would look like this. So I go over 1, 2, 3, 4, down 1, 2, 3. That's about what this line looks like. We can tell that just by the intercepts. X of +4, the y-intercept is -3. Okay, letter B. Let me bump this up to get a bit more space. Letter B. So we're finding the x and y-intercept. Okay, so the x-intercept happens when y equals 0. The y-intercept happens when x equals 0. Okay, so let's see. We are going to take when y equals 0. Now, I don't know if you noticed, but when you plug in 0 for this piece, it canceled it out both times. So when I plugged in 0 for y, that y piece was gone. When I plugged in 0 for x, that x piece was gone. So we can take a little bit of a shortcut here. Watch this. So if we plug in 0 for y, this whole piece is going to cancel out. So if I write just the equation 2x, I'm not going to put plus 0 or plus 7 times 0 equals 28. Because that piece right there canceled out. If we plug in 0 for y, 7 times 0 is 0. So 2x plus 0 is just the 2x. So I'm skipping this first line. Okay, now solve. To get the variable by itself, we have to divide both sides by 2. These cancel out. X equals 14. So this crosses the x-axis at the value of 14. I also like to write down the point. So 14 comma 0. Ooh. And on this side, this time the x value is 0. So this piece is going to be 0. So that piece is going to be 0. So when I write down my function, I just don't write down that piece. I start writing down with here, 7y equals 28, because I don't need a plus 0 out there. Okay? Solve. Divide by 7 on both sides. These cancel. Y equals 4. And that is the y-intercept. I also like to put down the point. So the x value is 0. The y value is 4. Not too bad. The part you got to remember is when the x-intercept happens, the y value is 0. At the y-intercept, the x value is 0. Go ahead and try this letter C on your own. Pause the video, do your work. When you're ready to hit continue, hit play, and we will go through it together. Alrighty. I'm going to get rid of letter B here. And that way we have space to do letter C. Okay, so. So I'm finding the x-intercept is when y equals 0. The y-intercept is when x equals 0. Okay. So if I plug in y here, this piece cancels out. I'd be left with a negative 4x equals 16. Because this piece would be 0. 6 times 0 is 0. And negative 4x plus 0 gives us this. Okay, then we're going to divide by a negative 4 to cancel out the times by negative 4. X equals 16 divided by negative 4 is negative 4. That's the x-intercept, and the point, because I like to put it, is negative 4, 0. This y-intercept happens when x is 0. So if I plug in a 0 for x, now that piece is 0. Negative 4 times 0 is 0. So I'm just not going to write down that piece. So I start writing down 6y equals 16. And then, let's see. To get rid of a times by 6, we divide by 6. Divide by 6. These cancel out. Y equals, and 16 divided by 6. 2.6. And that'd be it. Oh, we can put down a point. The point, the x value would be 0 for the point, and the y value is 2.6. Okay, so you saw that these are not terribly hard. Please go ahead, and I have a couple problems from the textbook for you to try. Do numbers 1, 2, and 3. You're just finding the x and y intercepts from each. Again, pause the video, do them on your own. When you're ready to continue or you want to check your work for a problem, hit play, and we'll go through them together. Okay, number 1. So x-intercept is when y equals 0. Y-intercept is when x equals 0. On this side, if I plug in 0 for here, this piece cancels out, so I get 3x equals 6. Divide by 3, divide by 3, cancel, x equals 2. That is the x-intercept. I also like to write down the point. The x value is 2, the y value is 0. Other side. X value is 0. So if I plug in 0 for x, this piece cancels out. I get 2y equals 6 left over. Divide by 2, divide by 2. These guys cancel. Y equals 3. And then my point happens, the y value is 3, the x value is 0, and there's number 1. Okay, number 2, same deal. X-intercept happens when y equals 0. The y-intercept happens when x equals 0. So if I plug in 0 here, this piece is canceled out. I get 4x equals 10. Divide by 4, divide by 4, x equals, let's see, 10 divided by 4 is 2.5. And on the other side, if I plug in 0 for x, 0, 4 times 0 is 0, so this piece canceled out. I have a negative 2y equals 10. Yes, you do still need that negative. Remember, the negative is with the 2, not with the 4, so this is a negative 2. Now we divide both sides by the negative 2. These cancel. Y equals 10 divided by negative 2 is a negative 5. And so here we would get the point 0, negative 5. And here we would get the point, the x value is 2.5, the y value is 0. Lastly, number 3. X-intercept is when y equals 0. Y-intercept is when x equals 0. We can squish it in there. Okay. So if I plug in 0 for y, that piece is 0. 5 times 0 is 0. That piece cancels. So I have a negative 3x equals negative 15. Divide by negative 3 on both sides. These cancel. X equals 5. So I have the point, the x-coordinate is 5, the y-coordinate is 0. On the other side, when I plug in x, or 0 for x, so that piece is 0, negative 3 times 0 is 0. I get a 5y equals negative 15. Divide by 5, cancels out. Y equals negative 15 divided by 5 is a negative 3. So I get the point, the x-coordinate is 0, the y-coordinate is negative 3. So there we are. We found our x and y intercepts. Now, if you cannot do this yet, it's going to be very hard to actually do the graphing. You have to be able to find your x and y intercepts to graph the lines. Here's why. Our example 2 here says graph the equation, and it just gives us an equation. Well, the way we're going to do this is on our paper we're going to find our x and y intercepts. So for example, the x-intercept is when y equals 0, y-intercept is when x equals 0. If I plug in 0 for y, that piece is 0, so 2 times 0 is 0. I got x equals 4. I didn't even have to solve that one. Sweet. On the other side, if I plug in 0 for x, that piece is 0, so I get 2y equals 4. Divide by 2, y equals 2. So looky here. If you could not do that thing before, you're not going to get these numbers. And now look how simple this is. We're going to plot a point on the x-axis at 4. X-axis at 4. On the y-axis at 2. That is our line. I'm going to try to freehand this line best I can through those 2 points. It's close. But that's our line. Use a straight edge or a book or something like that. I can use my line tool if I really want to get fancy with it. There. That's our line. Going through those 2 points. And notice how so much simpler that was. That didn't involve making XY table, picking a bunch of random X values, plugging them in for the Y values, doing all that math, solving for Y. It was a lot less work. The catch is, this method won't always work. This method only works if your equation is in standard form. If you remember, standard form was one of our vocab words the other day. And standard form is when you have ax plus by equals c. When you have both your x and your y variable on one side of the equation, and your things without an x and a y, your constants, on the other. So you'll notice every single equation today is in standard. X and y on one side, everything else on the other. If the equation is not in standard form, this method doesn't work so well unless you change the equation into standard form, which will be a large chunk of what Chapter 5 is all about. And actually a little bit later in Chapter 4 as well. So, let's do some graphing. Pop him up just a little bit more space. Alright, so x-intercept happens when y equals 0. Y-intercept happens when x equals 0. So when y equals 0, so 0, so that piece is 0. So we get 4x equals 24. Divide by 4, divide by 4. These cancel. X equals 6. So even right there, I can say 1, 2, 3, 4, 5, 6. Right there, my line is going to cross through that point. I don't know if the line's up here or down here or over here someplace, but I know it's going to go through that point. Okay. Second one is when the x value is 0, so that piece is 0, so that piece is 0, so we get 8y equals 24. Divide by 8, divide by 8, these cancel, y equals 3. So now we know the y value is 3, and there's our line. I'm going to cheat this one. My last freehand didn't do so good. So there we go. And I guess we should have arrowheads. So that is our line that goes through the x-intercept of 6, the y-intercept of 3. Pretty straightforward, pretty simple. I would like you to do letter C. So please graph this equation. I give you a nice big graph space there. Go ahead, find your x and y intercepts, graph the equation, and then when you're done, hit play on the video and we will go through them together. Okay, let's see how this does. I'll work over here. So we're going to find our x-intercept happens when y equals 0. The y-intercept happens when x equals 0. So if I plug in 0 for y, that's 0, so that's 0, I get a negative 3x equals 12. The way you get rid of a times by negative 3 is you divide by negative 3. On both sides, these cancel. X equals negative 4. On this side, let me Alright, x equals 0. So 0, 0. We get 3y equals 12. Divide by 3, divide by 3. These cancel. Y equals 4. So there's the x-intercept. There's the y-intercept. And we'll freehand this guy. And there's our line. That was close. Now, so far we've been doing the harder stuff for the day. We've been taking the equation and finding the x and y intercepts and then graphing. Well, if you notice on your note sheet, now we have a picture that it wants us to find the x and y intercepts for. Pretty easy. All you do is you find where those things cross. So let's see, this guy here, this letter A, it crosses the y-intercept there, it crosses the x-axis there. So my x-intercept is at 1, 2, 3. My y-intercept is a negative 1, -2, -3. That's literally it. That's the entire problem. That's how simple this part is. Letter B. We got a crisscross there and there. So this is the x-axis, that is the y-axis. So we cross it 1, 2, 3, 4, 5 in x, and 1, 2 in y. So you're finding where it's crossing the x and y axis. Please do letter C on your own. So you have the line. Go ahead and find your x and y intercepts right now. Alright, hopefully you found that is the x-intercept, that is the y-intercept. The x-intercept is at -1, the y-intercept is at 1, 2, 3, 4. That is a -5. Yeah, this point right here is not the crisscross. If you look at where the line, where these two lines crisscross, where it's the narrowest, right about there-ish, but closer to 5 than 4. So we're calling that one the intercept. Okay. Last thing is the now your turn. So on page 226, numbers 4 and 5, I gave a little graph space in case you need it. Number 4 says graph this, label the points with a line across the axis. So graph it here or on your note sheet, and then label the x and y intercepts. And number 5 says identify the x and y intercepts from this graph. So go ahead, pause the video, do these two problems. When you're ready to continue, hit play and we'll go through them together. Okay, let's do number 4 first. So we're going to find the x and y intercepts and graph that. So x-intercept is when y equals 0. Y-intercept is when x equals 0. So if I plug in 0 for y, 0, I get 6x equals 42, divide by 6, divide by 6. X equals 42 divided by 6. Does that go in evenly? Yeah, 5 plus another 2, 7 times. Yeah, 6 times 7 is 42. Yeah, I can math. And then on the other side, we got x is 0, so that's 0, so we get 7y equals 42. Divide by 7, divide by 7, y equals 6. So I have an x value of 7, 1, 2, 3, 4, 5, 6, 7. A y value of 6, 1, 2, 3, 4, 5, 6. I'm finding you drawing an extra dot or line or something. And there we go. This is where this is what this line would look like. It crosses the x-axis 7, the y-axis at 6. And what did it say? Label the points where the line crosses the axis. So y-intercept, x-intercept. Groovy. Number 5, identify the x and y-intercept in the graph shown. Okay, so we're just going to find them. So let me say the x-intercept is, and the y-intercept is what? Okay, so x-intercept on the x-axis is at -1, -2, -3, -4. The y-intercept is on the y-axis at +1, +2. And we're done. Okay. In the summary box in your note sheet, go ahead and say what makes graphing using the intercepts an easier way to graph linear equations. So, did you find today to be much easier? If so, why? Okay. Hopefully you had time to write it down. If not, go ahead and pause the video and give yourself an extra couple seconds to write down your response. But I would probably say something like, it's an easier way because you don't need to make an XY table. You don't need to solve the equation for y. And in these problems, I don't know if you noticed, but we were only finding 2 points. We were just finding that point and that point. Or if we do one of these guys, that point and that point. When we were doing the x, y table, we put in like 4 or 5 different x values and then found them all. Here we're only finding 2 points and using that to graph. And homework comes from page 229, numbers 3 through 30, multiples of 3. So again, multiples of 3 are like 3, 6, 9, 12, 15, 18, dot, dot, dot. You know, count by threes, or the times tables of 3. All right. So this has been lesson 4.3. Thank you for watching. This has been Mr. Henry. Goodbye.